So we're going to do the complex root theorem. I'm going to do a longer problem out of the book of the rational root theorem that allows us to see upper bound, lower bound, intermediate value theorem, all the fun stuff. But let's start with the complex root theorem since that's where I ended off. So this is still 3, 4.
When's the test for this?
Probably next Thursday. I want to get it quicker, but I think we better run out of time. So that leaves me a week to do chapter 4 as much as I can. It's a quick little chapter, but I'm only going to summarize it. And then the final. Woo-hoo. So, complex root theorem. Just to elaborate on it again. Given p of x as real coefficients and one of the roots is a plus bi, then a minus bi is also a root. What are those two called? Conjugates. So if you have a complex or imaginary root, the other one is its conjugate automatically. Which is kind of neat. So for example, a simple one. Oh, I run out of room there. Given p of x is a degree 3 poly with real coefficients and roots x equals 2 and I, and p evaluated at 3 is equal to -10. This last little piece, this p of 3 is equal to -10, I'll explain in a second. It requires a little bit of explanation as we get near the end. Okay. Now there was a couple other theorems that we talked about last time. One of them was the n zeros theorem and the n roots theorem. Now if we're talking about roots, remember roots can be real or imaginary complex, where zeros have to be real values only. So if we're talking about the n roots theorem, and we have a degree 3 polynomial, how many roots should we have? 3. Exactly 3. The n zeros theorem says you had at most 3. The n roots theorem says you have exactly 3. So we have to find all 3. The problem is I only gave you 2 of them, a 2 and an I. So what's the third root? If a plus bi is one of the roots, then a minus bi is the other. So I have I here is the imaginary one. So what's its conjugate? Negative I. Why would I care about the 2? 2's real.
I don't know, because I wasn't here last time, so.
If you multiply them together, but I'm saying that if you have I as one of your roots, then negative I has to be the other root. Because they are conjugates. The a would be equal to 0. If one's positive I, the other one has to be negative I. All right, so here's my 3 roots. The next part is, how do I write it in factor form? How do I write each one of these roots as a factor form? In other words, how do I write, or where did 2 come as a solution? I mean, seriously, where did 2 come from? How do I write it in factored form? Oh my Lord. If I have x is equal to 2, how do I undo what I solved? Well, I move the 2 back over. And if I move the 2 back over, what do I get? X minus 2.
Oh.
That's where the root's coming from. So this would be the factored form. This is the solution. We've done this before. All right. So 2 becomes x minus 2. I becomes x minus I. And negative I becomes x plus I. The trick is it's always going to be x minus the root. X minus the root. It always undoes what was done. So this is my polynomial setup for p of x, except there's something else weird going on. We'll have to talk about that in a second. Out of these 3, which 2 would you multiply together first? Yeah, definitely multiply these 2 conjugates together. So we're going to get x minus 2 times, what's x minus I times x plus I, since they're conjugates? It's x squared.
What is the I squared again?
Oh, what's I squared equal to again?
It's -1.
Negative 1. So it's x squared. Negative I times positive I is negative I squared, so negative I squared is really plus 1. And the middle 2 terms cancel out because they're conjugates. All right, and then multiply it together a little bit more. It'll give you x cubed minus 2x squared plus x minus 2. Now, we have to deal with this part. We're done with the roots. We're done with the degree 3. We have a polynomial that does have roots 2i and negative I. The problem with that is this. If I give you a polynomial, and let's say it has 3 roots, how many graphs of degree 3 goes through those 3 points?
3.
Just 3? Well, let's see. I can draw this graph.
Oh.
I can draw this graph. Right? I can draw this graph. Maybe the other way.
Okay, infinite.
It's going to be an infinite number of them. But here's what's really cool. This is a fixed point. This is 3, negative 10. So if I go to 3, negative 10, maybe it's down here. What it does is it fixes exactly one polynomial that goes through all 3 of those points and has that as a coordinate. So once we fix one point of the graph and its x-intercepts, we're guaranteed to be talking about a unique polynomial. So all this p of 3 equals negative 10 does is it makes us think about the unique graph that has these roots. So here's what we're going to do. We're going to let this one equal f of x. I'm not sure if it's exactly p of x. It's just one of the functions that goes through those points, through those roots. And what we're going to need to do, since this is p of 3 is equal to negative 10, we're going to have to evaluate this function at where? Which is equal to?
What else?
Well, what am I plugging in here? 3, and I expect to get negative 10. So what should I plug into f of x? 3, and see what happens. So we're going to do f of 3, which is equal to 3 cubed minus 2 times 3 squared plus 3 minus 2. Let's see, that's 27 minus 18 plus 1. This is 10.
It's not negative.
But the answer is supposed to be negative. So how do I change f of x so it relates to p?
Make it negative.
Change the entire thing to its opposite. So this answer is off by a negative, so p of x must be equal to negative 1 times x cubed minus 2x squared plus x minus 2. And that would be my final answer. The answer was off by just a negative. Now, it could be off by a little bit more. My next one is off by a little bit more. And it's a little harder to do, but the process stays exactly the same. So this is the polynomial p of x that goes through those 3 roots and has a point value of 3, negative 10 that is on the graph. Isn't that neat? By the way, when I come up with your rational root problems, I start with the roots, so I already know what the answers are. And then I multiply them all together and give you that, and you have to go backwards and come back up with the roots. So it's a neat little trick.
Where will we use this in our daily life?
What did I tell you about this entire class?
You won't.
You won't. It's not that you're going to use these tools specifically. It's just that with your brain wrapping around all these ideas, it's able to wrap around new ideas. which means I'm training your brain. That's my job. Train your brain to think better than it does already.
But I know some of them use like carpenter and stuff. Some of the
No,
things
that's
you
geometry.
Dude,
That's pure geometry.
Trust me, you never come anything close to this.
No, not in the real world.
like
But,
finding the
but
areas.
being able to think about these things.
Although I have to admit, last section,
Like the area and stuff like that.
no, there was a couple of equations last section.
Midpoint, distance, slope.
No,
Average
those
rate
two,
change.
but no, there was some word problems at the back. Last section was
Applications.
about fences and gutters and
Yeah,
stuff like that.
yeah. Maximizations.
That I was able to do in my head.
Yeah, but those are calculus problems. That's the beauty of them. Calculus is always applicable. You want to learn
I do it in my
calculus?
head, but I couldn't explain how.
You want to learn calculus?
No,
I mean, if you want to apply math, you have to start with calculus and build your way through differential equations.
Well,
No, that's all right.
19.
All right, so let's try another one. A little longer. P of x, degree 3. I don't go any higher than degree 3. If you can do it with a degree 3, you're fine for most of them. Roots of, let's see, what did I? 1, 4 minus 3i. I'll leave a little room there. And p evaluated at 4 is equal to negative, where is it? Negative 54.
Is there supposed to be a comma in between that, or is that no? 4 minus 3i?
Mm-mm.
It's actually
4 minus 3i is your complex root.
Oh.
Don't be separating them. It's not 4 minus 3i.
Just checking.
So what's the root that's missing? Because I need 3 of them. 4 plus 3i, the conjugate. So you have to come up with that one on your own. Now this one gets a little messier, but there is a little shortcut I can show you, and I'm not a fan of shortcuts except for this one, because otherwise it's horrid. How do I write these in factored form? Now remember, it's x minus the root, whatever the root is. So the first one is going to be x minus 1. The second one is going to be x minus the root. Now since the root has 2 pieces, I'm going to need to put it inside parentheses. And the root is 4 minus 3i. All right. The next one is x minus the root.
4 plus 3.
And the inside here goes 4 plus 3i. Now, with the last problem, which was, x minus I, x plus I, those were easy to multiply together. They're just pure imaginary numbers. This process isn't that bad. But this is not a pure imaginary root. These are complex roots. And they tend to be messy. So you could sit here and FOIL this mess out. The problem with foiling this mess out is you have 3 terms in each one of them. So that means you have a trinomial times a trinomial and a lot of work going into it. So there's got to be a better way of doing that. What's algebra? What's the purpose of algebra? No, it is not.
Confusion.
No. The simplest definition of what algebra is.
Math.
To explain something.
Now.
Numbers.
What about, no? Do you see numbers up here really seriously?
Letters.
Letters. What do the letters represent? Numbers. So algebra, the whole basis of all algebra is letting letters represent values. Letting letters represent values. So what I'm going to do is I'm going to use algebra. I don't like this. That is messy. So I'm going to represent it with a letter. A. Can I do that?
Sure.
We don't know.
You can.
I mean, that's what algebra is about, is replacing numbers with letters. I also don't like this one. So I'm going to replace it with B. Why not? Oh, excuse me.
Are you okay?
So I'm going to change that into x minus A and x minus B. Totally legal. Where A represents 4 minus 3i and B represents 4 plus 3i. So FOIL this out, what do we get? Well, we get x squared minus ax minus bx plus ab. Now, we did this way back at the beginning of the semester, playing around with factoring and stuff. Can I combine the middle 2 terms? How?
Not in this case.
Negative 2ab x.
Not in this case.
Hmm?
In this case?
Yeah. Can I combine the middle 2 terms? We've done this before.
Will it be Yeah, except the X, right?
There's an x common between both of them, and, by the way, a negative. So what can I do with the negative and the x?
Factor it.
Factor it out. So the way I'm going to factor it out is a little messy. I'm going to factor out the x to the back and the negative to the front. Totally legal to bring it in two different directions. Because then the negative will distribute and the x will distribute. What's it left on the side?
A
B.
A times b?
A minus B.
A minus b?
A plus B.
Which one?
A plus B.
A plus b. Because you're taking out the negative, they become
Oh,
positive. And then at the end you have this plus AB. So to figure out this product up here, oop, I boxed it on too short. All we have to do is add A and B, multiply A and B. So if I take A and B and I add them, let's see here. 4 minus 3i plus 4 plus 3i. What's that equal?
Not a thing.
Yes, it does.
8.
8. I mean, the negative 3i and the positive 3i will cancel, but 4 plus 4 is
Okay.
8. So I can replace a plus b with 8. So this becomes x squared minus 8x. So far. Now I need to do a times b. Well, a times b is 4 minus 3i times 4 plus 3i. What's that equal to?
16.
12I minus 12I equals negative.
No. There's no equal sign
I'm
here.
sorry. Minus negative 9I squared, which will be
16.
positive 9.
I mean 16 plus, oh no.
Which is?
17, 18, 19, 20.
Oh my lord!
25.
Counting in your fingers. 25. So we get plus 25. So x minus 4 minus 3i times x minus 4 plus 3i is equal to x squared minus 8x plus 25.
So if we see that right there,
Complex, replace it with a.
always
Replace it with
replace with A.
and, or you can just memorize this little formula
Yeah.
where you add them together, change the sign, multiply them together, put the numbers in. It's not that bad. So this becomes my triangle part. Don't forget the x minus 1.
But with that little formula you told us to memorize, that's always the same.
Yeah, because whenever you replace a, it's going to be x minus a, x
Oh,
minus
it's
b.
X minus.
Yeah,
Okay,
because
I
it's
get
x
it.
minus the root.
Yeah, I get it.
Okay, now I need to multiply those two together. X cubed minus 8x squared plus 25x. And then it's going to be minus x squared plus 8x minus 25. Because you just have to multiply through by a negative 1. And that gives you x cubed minus 9x squared plus 33 minus 25. So this is what I end up with after I multiply it all together. So I'm going to call that f of x.
Where did the ax cubed or the x cubed come from?
What x cubed? Oh, this x cubed?
No, the first one.
Right here. X times x squared. Remember you have to distribute this?
Both of them.
Remember, I don't review polynomial multiplication.
I don't, sure, okay.
X times x squared, x times negative 8x, x times 25, negative 1 times all of these. Yeah, that's just stuff you should know how to do. Alright, so here's my f of x. But all I know about p is that p of 4 is equal to negative 54. So what do I need to do to this?
Plug in P of 4.
No, not p of 4,
I mean 4.
just 4. So f of 4 is going to equal 4 cubed minus 9 times 4 squared plus 33 times 4. Do you really want to do that?
Not
Why
really.
not?
Nope. So what I'm going to do is
Do any of
the other way of doing it. You could do this. You could type it in your calculator and get a nice answer. I'm going to do synthetic division.
Right, that-
Oh, because now we can do that.
Well, because we can use the remainder theorem.
Right. Well, that's what I
And
meant.
this is just multiplication addition where this is powers and it's just a
But wouldn't
mess.
it be easier just to put it in your calculator?
Do you have one?
Yeah.
Where is it?
In my book bag.
Yeah, good place for it. 4 times 1 is 4. 4 minus 9 is negative 5. 4 times negative 5 is negative 20. Negative 20 plus 33 is 13. 4 times 13 is 52.
See?
52 minus 25 is the answer. Which is-
Negative 4, 5.
What?
That's what my paper.
Well, your calculator is wrong. It's 27. Boy, synthetic division is better than the calculator. That's scary. But it is very precise. So this is telling me that f of 4 is equal to 27. But p of 4 is equal to negative 54. So what is the difference between negative 50? Well, what do you have to multiply 27 by to get to negative 54?
Two.
Negative 2. So my final answer is going to be p of x is equal to negative 2 times x cubed minus 9x squared plus 33x minus 25. And that is the polynomial that has these three roots, 1, 4 minus 3i, 4 plus 3i, and goes through the point 4, negative 54.
I have one question.
Go for it.
Maybe I'll understand it clear if I understand the purpose of this section.
The purpose of this section is...
Not dealing with life.
No.
or
It's
purpose.
roots. It's either finding the roots or using the roots to find the polynomial. Notice it's just going back and forth. Like for instance, if I was going to design a test question and I wanted these to be the answers, I would give you f of x here as the test question. You use the rational root theorem, break it all apart, come up with these answers. So I like knowing what the answers are before you even start. You can't just wing, I can't just write a polynomial up here and have it guaranteed have roots, nice roots, kind roots, because most of them have nasty, irrational, horrible roots. Okay, the next part is I want to do one of the problems out of the book. It's a horrid problem,
That's why you chose it.
and that's why I chose it. It is number...
4 or 5.
Which one was it? That one?
What page?
Or that one? Darn it, I can't remember which one I did. It's it doesn't matter. I'm just gonna write it on the board anyways. So let's see. Let's do this one. 2x to the 5th plus 7x to the 4th. Really feeling this one.
My calculator still
Yeah.
could be 4 or 5.
Minus 18. Well, and you better do some back division now. Minus 8x plus 8 is equal to 0. Let me see what I got there.
Mine's giving 27. Plug it in.
4 cubed. 4 cubed. 4 cubed minus 9 times 4. You wrote 4 cubed again. That's supposed to be 4 squared. Alright, I want to find all the solutions. How many solutions does this thing have?
5.
5. Horrible.
But you said
I'm trying to
it's
think
not
of
going to
this.
be any more than
3.
3.
Yeah. But I wanted to show you a longer one just to practice.
Okay.
Oh, wait a minute. Come on.
Okay. Is there anything missing?
Yeah, third.
The third power, right? So when we get to the third power, we're going to have to put in a 0. So we're going to start off with 2, 7, 0, negative 18, negative 8, positive 8. I really don't think this is the one I did in my other class. Oh well. Rational root theorem says you're going to take a sub 0 and divide by a sub, not 8, a sub n. So that would be 8 over 2. So what are factors of 8?
2 and 4.
1,
1,
2,
2, 4, 8.
4, 8. Factors of 2?
1 and 2.
1 and 2. So our list that we're going to be looking at is 1, 2, 4, 8. And what else?
That's it.
There's one more.
Here.
You take all the top numbers and divide it by 1. You take all the top numbers and divide it by
16.
2.
4, 2, 1.
Oh my lord. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. 1 divided by
2 is 1
is
half.
1 half. 2 divided by 2, 4 divided by 2, and 8 divided by 2 all reduce, so we already have them.
Okay.
So you were just missing the 1 half. Plus or minus. Yes, you have to divide every top number by every bottom number. In any order. I can care less what order you do that. We're going to do quick synthetic division.
You gonna do it quick.
Well, in the sense of I'm not going to keep writing it over and over and over again, those top numbers, because that gets tiresome. What number do you want to start with?
1.
Yeah, most people start with 1. Smart aleck. Drop the 2. 1 times 2 is 2. 2 plus 7 is 9. 1 times 9 is 9. 9 plus 0 is 9. 1 times 9 is 9. Minus 18 is negative 9. 1 times negative 9 is negative 9 minus 8 is negative 17. 1 times negative 17 is negative 17 plus 8 is negative 9.
Sure.
Yeah, come on, it's just 1 for God's sakes.
Sure.
That's why it's so nice and easy. Caution, if you're bad with signs, go slow. Better yet, use your calculator. Just remember that negative sign.
Go slow, how can we go slow?
No.
We're speedy and go.
Well, I'm just going to go through this to show you what's going on. Don't just sit there and stare at me. What number do you want to try next? Because obviously that did not work.
Deuce.
It did tell me some information. If I evaluate this thing at 1, my answer is negative 9. 2, drop the 2. 2 times 2. 4 plus 7.
11.
2 times 11.
22.
Plus 0 is 22. 2 times 22.
44.
44 minus 18. You all have calculators, I don't.
26.
44 minus 8 is 26. 2 times 26 is 54. 54 minus 8.
52.
Oh.
52.
Huh?
Shit, 20.
Oh, I'm sorry.
46.
52. 46. And 2 times 46 is a big, ugly, positive number.
92.
Yeah, it's 92.
I told you to skip the 4.
All right. Do you remember what this pattern tells you?
That tells you
Double.
Mm-mm. Oh, you weren't here, so you won't know. Positive, 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 positive. We talked about this, didn't we?
Yeah, we did.
Yeah,
I don't think we talked about the positive.
All positives.
If they're all positive, so we're gonna be up or back.
Up or back. So, that tells us that x equals 2. X equals 2 is an upper bound.
What's upper bound?
There are no roots larger than 2. If you plugged in the next number, which is 4, they would be all positive, and that last number would be even bigger. It would just be pulling away from the x-axis.
So be 1/2.
No, not necessarily. This does tell me something. Negative 9, positive 92. That means one point is below and the other one is
Above.
above.
So,
That means there has to be a
Number between them.
number in there.
root between these two by the intermediate value theorem.
And it's 1/2.
That's a big.
1/2 is not between 1 and 2.
It's
1/2 is between 0 and 1. But there is a root between these two. Now the cool thing about it is, it's not in this list, so it's not rational, but it's still real by the intermediate value theorem. And what kind of number does it have to be?
Irrational.
Irrational. If you can't be rational, you're definitely irrational. So there is an irrational root between 1 and 2. We'll find it later. What number do you want to try next? Since you can't try 4,
1/2.
we could try 1/2, but can we wait on that one?
8.
Oh, come on. We
That's
can't
so-
go bigger than 2.
That's the only
Negative.
1/2.
We can
Oh.
do negatives.
Negative.
So, -1. Why not? Bring down the 2. -1 times 2 is -2. -2 plus 5. -2 plus 5. -2 plus 7 is 5. -1 times 5 is -5 plus 0 is still -5. -1 times -5 is +5 minus 18 is -13. -1 times -13 is 13. Minus 8 is 5. -1 times 5
Negative.
plus 8. 3. It's 3. That's okay. I mean, that's fine. Next number you want to try?
-2.
-2.
What are we looking for? I don't.
What do we look for? 0.
She won't hear.
I know, 0.
Zero.
We're trying to find 0. If it's 0, it's an x-intercept. If it's an x-intercept, it's also a factor.
Okay, so we're looking for a remainder.
A remainder of 0. Drop the 2. -2 times 2 is -4 plus 7.
3.
-2 times 3 is -6 plus 0. That's easy. -2 times -6 is 12 minus 18. -6 again. 12 minus 8. -2 times 4 is -8.
-8.
Plus 8?
0.
0. Yay! Which means we just found a answer, a solution to this equation. That solution happens to be, let me do it in green. X equals
X equals
2.
-2.
-2. If we're going to write it in factored form, it would be
X plus 2.
x plus 2. So depending on if the question is asking for factors or if it's asking for roots,
So
You have both choices.
you said that was the negative 2 is the root.
Negative 2 is the root or 0,
Just
and the
make
factor
sure.
is x plus 2.
So when you get the upper bound and you get x equals 2,
All
you're
positive.
trying to find the opposite x plus 2.
Well, I can't go any big. Oh,
So you got,
here?
No,
If it's
you
x
see
minus?
the x minus 2 would be x equals 2 would be
That's an upper
x
bound. That
minus
has nothing to do with roots. That's just an upper bound. We're not going to go any bigger. That's all this is saying. Over here, when we get a remainder of 0, we're saying this is a root 0 factor.
Yeah, I know what you mean by that, but I'm saying it's x equals 2. So are you just
It's
trying
just
to
a
This is x equals negative 2. Yeah, this is just a coincidence. It's just, you're not going to go
If
any
that line
bigger.
had all been, if it had all worked out where they were all negatives,
You'll never get that.
then what makes it lower bound?
Positive, negative, positive, negative, positive, negative.
Oh, okay.
Alternating.
Alright.
Alright, so now this is a factor. We can use the factor theorem and say, oh, I don't need to go back to those top numbers anymore. All I have to do is work with these. Because this is the quotient times x plus 2 brings you back to the original polynomial. So you're going to write down 2, 3, negative 6, 4, and never go back to those top numbers again. Notice I'm using 2 colors. Hint, hint, hint. You might want to use like a red pen for that top line and then pencil underneath it or something. That way your eyes don't look at any of these other numbers.
Big
You have to go back to
bunch
the
of
top.
stars. We'll be all right.
Yeah, you have to go back to the top. All right, now what number should I synthetically divide by?
Negative 2.
Why negative 2?
No, hold on.
No, trust me. You want to do negative 2, but why?
Because it's
Because
a root.
If it's once a root, can it be a root again?
It can be.
It can be if it's a perfect square. So you have to try the answers you've already gotten to see if it works again. So try negative 2. If it works, great. If it doesn't work,
Wait a
at
minute.
least you
Oh,
could
no, okay, alright, I'm following you.
you could have something that looks like this.
I got you.
And that's what's considered a double root.
Right.
It'll happen twice.
Right.
So if it works once, there's nothing holding it back from working.
Working
Again.
Alright.
The problem with that is if you don't test it again, and you'll never find all the roots if it's a double root because you've skipped over it and you'll try all these
Right,
other
I got
ones.
you.
Drop the 2 from here. Negative 2 times 2 is negative 4 plus 3. Negative 2 times negative 1 is 2, 2 minus 6. Negative 2 times negative 4 is positive 8 minus 6. Huh?
2.
2. That's 8 minus 6, 2. Negative 2 times positive 2 plus 4. It is a double root. If we never tested it, we would have never have found it. So, lucky me. I also find that x is equal to negative 2 again, and it gives me another factor, x plus 2. Or we could say that negative 2 has multiplicity of 2. It happens twice. All right, now we're down to these numbers. Because we got a 0 at the end, we can break it down into a smaller polynomial. So this is going to be 2, negative 1, negative 4, 2.
So we keep testing the negative 2?
Until it stops. Because it could be a triple root. It could be a fourth root. All the way up to 5. And there could be 5 2's in this thing. So try negative 2 again. I will tell you this, it's not going to work again.
Okay.
Drop the 2. Negative 2 times 2 is negative 4 plus negative 1 is negative 5.
You talk too fast.
Oh, I go faster than this. Negative 2 times negative 5 is 10, 10 minus 6, 4 is 6, negative 12 plus 2 is negative 10. So it's not going to work again, which is fine. At least I got it out of the way. All right. What number do you want to try next?
Huh?
Dang.
No, we already tried negative 1. All these numbers that we've tried already, if they don't work,
Well,
they're
let's-
not going to work again.
Let's go with negative 4.
Negative 4. So, negative 4. We're getting down to the bottom here. Drop the 2. Negative 8 minus 1. Positive 36 minus 4.
Negative 40.
Positive 36 minus 4.
Oh.
Yeah, positive.
32.
It's positive 32. Negative 4 times 32. A huge, ugly negative number plus 2.
128.
It's going to be,
128.
I could care less. It's going to be negative.
Negative
It's going to be negative. What's wrong with that line?
to be
Positive, negative, positive.
So we gotta go
negative,
Positive, negative, positive, negative. That tells us that x equals negative 4 is a lower bound. I cannot go any lower than negative 4.
Yeah.
What does that leave?
Negative 3.
The one
There is no
half,
3 in my list.
Oh,
1/2.
The only thing left, we can't go bigger than positive 2. We've already tested -1, -2, +1, +2. We've tried 4, can't use 8. The only thing left is a half.
And that's what I said.
Should just
I know, but I told you I wanted to wait on that one for this reason.
we should just start.
You can
And we're not
try.
gonna have a class
Fractions are
like
messy
this,
to
right?
start with. So, put a half in.
So,
We're almost guaranteed that it works. We're almost guaranteed that it works. There's no guarantee of anything.
I'm running
does.
out of
you ignoring
space.
me.
Drop a 2. No, I knew what was going to happen. If I used a half too early, we would never find the lower bound. So, half of 2 is 1. 1 minus 1 is 0. Half of 0 is 0. 0 minus 4 is -4. Half of -4 is?
2.
-2 plus 2 is?
0.
Woohoo! So we have all our answers. Well, almost. I have almost all our answers. So this one tells, wrong color, green. This one tells us that x is equal to a half. Now, let me talk about the factor for a second. You want to write it as x minus a half.
Yeah, that's how.
I say that is ugly.
X minus.
I'm used to
5.
polynomials being no fractions, so what polynomial with no fractions has a solution of a half?
Huh?
If I was going to write a polynomial, and I say x is equal to a half, I don't like fractions. What's your first step?
What about 0.5?
So that gives you 2x is equal to 1. How do I get it equal to 0?
There's the one over.
And you get 2x
Minus 1.
minus 1. That's the factor I'd rather you write. So this 1/2 becomes 2x minus 1. That way you don't have any fractions in it at all.
Explain to me again.
I have x is equal to a half. I don't want any fractions, so you multiply both sides by 2, so you get 2x equals 1. To get it in factored form, you get it equal to 0, so you move the 1 over. So you get 2x minus 1. And if you set this equal to 0, the answer is a half. Yeah. And that way you don't have any fractions in your polynomial. Now we're down to 3 numbers. What's special about 3 numbers?
We just wasted a lot of class time on this.
Oh, but it's all these little important details in here.
And we won't have one
Well-
that's on the test, right?
Not this long.
Since it's to the
Neither.
3rd degree.
So, I have 3 numbers. What does that represent?
Third degree.
Mm-mm.
Second.
Second degree. It's always 1
That's
less
right,
than how
that's
many
right,
numbers there are.
because
So that's 2x squared minus 4, and we want to set it equal to 0. How do you solve?
Add 4.
Add the 4. So you get 2x squared is equal to 4.
Plus or minus.
X squared is equal to 2. And x is equal to plus or minus square root of 2. Now remember earlier when I said there was a root between 1 and 2?
There it is.
Square root of 2 is between 1 and 2, and it was irrational. So the final answer for this, I'll write it just below the
The final.
equation. Yeah, x is equal to. My answers are all over the place.
Yeah, I see
They
that.
are.
So I need to bring them all together. So what's the first answer I found?
X plus 2.
-2.
Oh.
And if we want to be precise,
All
it
right.
has multiplicity of 2. That just reads -2 with multiplicity of 2. Comma, so that's 2 roots.
2x minus 1.
Root, not factor.
Oh, 1/2.
1/2
And then that down
Plus or
there.
minus.
of positive square root of 2 and a
Negative square.
negative square root of 2. So positive square root of 2, negative square root of 2.
Can I ask, okay, I was copying something now.
Where,
What, -2
With
times
multiplicity of 2, because it happens
Twice.
twice. If you want to be precise, you don't have to, but I'd rather
Just
you do
write twice. We'll be all right.
Now, why do I do that? Well, this says there's 2 roots. That would be 3. That would be 4. This would be,
5.
and that's how many I'm supposed to have.
So you wouldn't be
Well,
upset
negative
whenever we wrote -2 and -2.
No, oh no, I wouldn't be upset
Yeah.
with that. It's just shorthand notation.
I didn't write that on my notes.
Wow, that was hard, wasn't it?
Just write it down.
Horrible.
Yeah, that's what I did, wrote it down twice, because I was getting home like, what?
I write an X in there.